Iron should not survive for 1,000 years. Wood should not withstand ice, sea salt, and northern storms. Ships built without industrial nails should not cross open oceans. Isolated communities should not thrive in territories where winter tries to erase any sign of human life. And yet, they prospered. For centuries, the popular image of the Vikings has been reduced to brutal warriors sailing in search of plunder. A people guided only by strength, violence, and primitive survival. But recent archaeological excavations tell a radically different story. Beneath layers of frozen earth, silent fjords, and ancient abandoned farms, researchers began to realize something disconcerting. The Vikings were not just explorers of the sea. They were engineers, technologists, meticulous observers of nature. Many of the solutions they developed disappeared over time, not because they failed, but because the modern world took a different path. Mass production replaced durability. Speed replaced in-depth knowledge of materials. And so technologies were born that today seem impossible for a society considered medieval. Some were abandoned, others forgotten. Some, curiously, seem to have been deliberately ignored by subsequent industrial development. Technologies that modern scientists are now beginning to reconsider. The first revelation emerges in the very symbol of Viking expansion: the longship. For decades, historians believed that the success of these ships stemmed solely from naval skill. But modern structural analyses have revealed something more complex. The hull was not as rigid as that of later European ships. He was flexible. The overlapping planks, a technique known today as clinker construction, created a structure capable of twisting gently with the waves. Instead of fighting against the ocean, the ship adapted to it. Hydrodynamic tests show that this flexibility absorbed energy from storms, reducing structural fractures that would destroy modern rigid vessels. It was a different philosophy of engineering. Do not dominate nature. Cooperate with her. This logic reappears in the second forgotten technology: the shallow keel. Modern ships rely on deep harbors. The Vikings did not. Their vessels could sail on the open sea in the morning and, hours later, glide through narrow rivers or be pulled directly onto the beach. This absolute mobility transformed geography into a strategic advantage. Today, military engineers are studying similar concepts for modern amphibious vessels. What seemed like simplicity was, in fact, extreme adaptability. But perhaps the most surprising discovery lies far from the sea: inside Viking houses. For a long time, longhouses were believed to be merely rudimentary shelters against the cold. However, modern thermal analyses have revealed an impressive passive climate control system. The peat walls provided more than just insulation. They were living temperature regulators. The compacted earth stored heat during the day and released it slowly during the night. The natural humidity stabilized the internal air, preventing excessive freezing and also overheating near the central fire. Without metal, without electricity, without formal mathematical calculations, the Vikings had created a sustainable system of energy efficiency, something that contemporary architects are revisiting under the name of bioclimatic architecture. The fourth technology is emerging from the forges. Viking iron often exhibits levels of corrosion resistance that intrigue modern metallurgists. Recovered samples show complex microstructures formed by the repetitive forging process and the use of specific charcoal. The result wasn't just metal. It was a living material, full of microscopic layers that slowed down oxidation. While modern steel strives for uniformity, Viking iron embraced structural imperfection and found durability in it, a logic that is the opposite of contemporary industry. The fifth technology was not an object, but a navigation system. Without reliable magnetic compasses, the Vikings crossed the North Atlantic centuries before the great European explorations. For a long time, this was attributed to luck or instinct, until scientific experiments recreated the use of so-called sunstones. Crystals capable of polarizing light made it possible to locate the sun, even under cloudy skies or thick fog. Modern tests have shown that its accuracy could rival that of later, primitive nautical instruments. It wasn't superstition. It was applied optics, centuries before it was formally understood. And then, an inevitable question arises. How many other technologies have been lost, not because they were inferior, but because the world stopped looking to nature as a teacher? As excavations continue to reveal fragments of this forgotten knowledge, a new understanding is beginning to take shape among archaeologists and engineers. Perhaps the Vikings were not ahead of their time. Perhaps they followed a different technological path, a path that modernity has abandoned. And only now are we beginning to realize what has been left behind. True technological advancements rarely seem revolutionary at the time they are born. It emerges silently, integrated into the daily routine, invisible to the user. Among the Vikings, many of the most sophisticated innovations were not found on the battlefields, but in the simple gestures of everyday survival. The sixth technology begins in the cold. Excavations in settlements in Iceland and Greenland have revealed something unexpected beneath the floors of the houses. Carefully positioned drainage and ventilation systems. Small channels carried cool air under the structures, while smoke from the central fire was directed through specific openings in the roof. The result was a delicate balance. The air remained breathable even indoors during the winter months. Humidity did not accumulate. Mold was reduced. The temperature remained stable. Today, architects call this intelligent passive ventilation. For the Vikings, it was simply a matter of well-thought-out survival. The seventh technology is appearing in agricultural fields. Contrary to the myth that they were merely plunderers, the Vikings developed agricultural systems highly adapted to poor soils. Instead of trying to impose traditional European methods, they mixed ashes, organic remains, crushed bones, and seaweed into the soil. This process regenerated nutrients rapidly. Modern analyses show a significant increase in fertility, even in lands considered unproductive. Centuries later, similar techniques would be rediscovered by modern regenerative agriculture. They did not cultivate against the land. They cultivated it alongside her. The eighth technology was in food. Fermented fish, meats cured in the Arctic wind, dairy products transformed by natural bacteria. What was long interpreted as simple rustic preservation has revealed itself to be a sophisticated microbiological system. Controlled fermentation increased the shelf life of food and, more importantly, preserved essential nutrients during long, unharvested winters. Modern researchers have identified elevated levels of probiotics and vitamins in samples recreated using these techniques. Before the science of microorganisms, there was already food engineering. The ninth technology emerges from the ice. The Vikings used sleds and sliding systems designed to reduce friction on frozen surfaces. Recent studies show that the specific curvature of the blades distributed body weight optimally, allowing for the transport of heavy loads with minimal effort. It was applied physics without written formulas. Observation transformed into efficiency. Today, similar principles are used in modern polar equipment and logistics in Arctic regions. The 10th technology is perhaps one of the most surprising. Lighting. In regions where winter plunged entire communities into months of darkness, the Vikings developed carefully designed animal fat lamps. The shape of the stones or containers directed the heat to keep the fuel liquid while producing a steady, long-lasting light. It wasn't just lighting. It was energy management. Each flame needed to last as long as possible when resources were scarce. Nothing could be wasted. And then a pattern emerges. None of these technologies sought excess. None depended on an infinite abundance of resources. They all stemmed from the same invisible principle: efficiency through adaptation. While later civilizations would advance toward mass production, the Vikings perfected something different: resilience. Each tool, each house, each agricultural or food technique functioned as part of a larger organism. The human settlement integrated into the hostile environment. Perhaps that's why so many of these solutions have disappeared. They didn't fit into an industrial world based on global standardization. And so, knowledge was slowly left behind. Not destroyed, simply forgotten. But the more modern science confronts climate crises, energy scarcity, and environmental limits, the more researchers turn their attention to these ancient societies, not in search of nostalgia, but in search of answers. Because hidden beneath ice, peat, and rust, there still remain technologies that challenge the modern idea of progress. Technologies that failed to conquer nature, but they learned to survive within it. History often celebrates inventions that have visibly changed the world. Great machines, monuments, weapons capable of redefining empires. But among the Vikings, some of the most extraordinary technologies were almost invisible. Silent systems that enhanced human capabilities without drawing attention to themselves. The 11th technology is born from the very landscape of the North. Long before modern naval engineering fully understood the behavior of ocean currents, Viking navigators were already using routes based on animal migration patterns, cloud formations, and subtle changes in water color. Observations accumulated over generations transformed the ocean into a living map. They didn't just navigate through space, they navigated by the behavior of nature. Modern oceanographic research demonstrates that many of these routes coincided with natural corridors of lower turbulence and greater energy efficiency. This reduced crew effort and dramatically increased the chances of survival on long voyages. It was a technology without a physical instrument. Collective knowledge transformed into a navigation system. The 12th technology appears in clothing. Textile fragments preserved in tombs and settlements have revealed fabrics that were extremely complex for the time. Layers of treated wool created microscopic air pockets that retained body heat even when the fabric became damp. The secret lay not only in the material, but in the way it was woven. Fibers twisted in specific patterns repelled wind and retained heat without hindering skin respiration. Modern tests show thermal performance comparable to technical clothing used today on polar expeditions. They had mastered thermal insulation centuries before the science of synthetic polymers. The 13th technology emerges in the form of shields. Often depicted solely as instruments of war, Viking shields reveal astonishing engineering. Constructed from lightweight wood, reinforced with leather and metal only where necessary, they absorbed impacts rather than simply withstanding them. The slight flexibility dissipated the energy of the blow. Modern engineers recognize the same principle in safety helmets and automotive impact-absorbing structures. It wasn't brute force, it was intelligent energy management. The 14th technology is found in social organization. Unlike many rigidly hierarchical European kingdoms, Viking communities used assemblies known as things. Collective decision-making systems where conflicts were resolved through consensus and public negotiation. It may seem far removed from physical engineering, but modern social scientists observe something essential. Social stability is also a technology. These systems reduced internal conflicts, maintained community cooperation, and allowed for rapid adaptation to environmental crises. A functional society was itself becoming a survival machine. And then we come to the 15th technology, perhaps the most difficult to understand because it leaves no clear archaeological traces: the Viking mindset in the face of risk. Exploring uncharted seas without complete maps required more than courage. It demanded a collective psychological model capable of balancing prudence and daring. Ancient texts describe meticulous planning before voyages, study of the seasons, precise food preparation, and constant observation of natural signs. The risk was never random. It was calculated. Contemporary researchers would call this a highly resilient adaptive culture, a mindset that allows for continuous innovation without social collapse. At this point, a definite pattern begins to emerge. None of these technologies sought to dominate the world through excessive control. They worked because they accepted natural limits and operated within them. Perhaps that's why many were abandoned. The Industrial Revolution rewarded speed, scale, and uniformity. Systems based on patient observation and local adaptation became incompatible with a standardized global model. Knowledge did not disappear all at once. He was gradually replaced, simplified, forgotten, until only fragments remained. Buried ships, corroded tools, fossilized tissues, and stories passed down as myths. But as modern scientists reconstruct these fragments, a disturbing realization grows. Perhaps technological advancement is not a straight line. Perhaps there are parallel paths to innovation, some abandoned too soon. And perhaps the Vikings followed one of those paths. When archaeologists began to reconstruct Viking settlements on a full scale, something unexpected happened. The structures functioned better than expected. Houses retained warmth without modern technology. Workshops produced durable tools using ancient methods. Rebuilt ships braved violent seas with surprising stability. What for centuries had been treated as primitive knowledge began to challenge deeply ingrained assumptions about humanity's past. The question is no longer asked, how did they survive? It became what we forgot. A recurring observation emerged from these experiments. Viking technologies rarely existed in isolation. Each innovation depended on another. The ship depended on the forest. The forest depended on sustainable management. Settlement depended on climatic knowledge. Survival depended on the balance between all these elements. It was an integrated system. Ecological engineering even before the concept existed. In Viking shipyards, for example, no tree was chosen at random. Dendrological studies show that builders selected logs whose natural curvature already matched the desired hull shape. Instead of forcing the wood to assume a new structure, they sought the ready-made form in nature. This reduced internal stresses in the material. The ship was born more resilient because it wasn't fighting against its own composition. Today, structural engineers are rediscovering this principle in biomimetic designs, buildings directly inspired by natural patterns. The Vikings already practiced this intuitively. Another frequently overlooked element appears in the use of time. Industrial societies measure productivity by speed. Among the Vikings, many processes were deliberately left unhurried. Drying wood, fermenting food, tanning leather, and forging metal required complete natural cycles. Waiting was part of the technology. Haste would ruin the result. This relationship with time produced objects designed to last generations, not seasons. Swords were passed down from father to son. Houses were expanded, not replaced. Tools were repaired repeatedly. Durability wasn't just about material efficiency. It was cultural philosophy. And then an even deeper discovery emerges. Climate researchers analyzing historical records have found that Viking settlements often survived periods of environmental instability better than contemporary agricultural communities in other regions of Europe. The reason was not military force, it was adaptability. They diversified their resources: fishing, animal husbandry, trade, seasonal agriculture, and maritime exploration coexisted. If one source failed, another sustained the community. It was planned redundancy, a central concept in modern complex systems engineering. Perhaps that's why so many Viking technologies seem strangely modern today. They weren't aiming for maximum efficiency under ideal conditions. They were seeking survival in unpredictable conditions, and that difference changes everything. Modernity was built on stability, abundant energy, global supply chains, continuous production. The Vikings lived in an opposite world: extreme cold, isolation, scarcity, and constant risk. Its technological advancement was born from uncertainty. Each innovation was a direct response to the hostile environment. And as scientists recreate these practices, a quiet awareness begins to spread among researchers. Many of these technologies didn't disappear because they were inferior. They disappeared because the world believed it no longer needed them. But now, faced with new global challenges, climate change, energy crises, and the fragility of modern systems, the past is beginning to seem less distant, as if the knowledge buried beneath ice and earth was waiting for the right moment to return. Perhaps the true Viking legacy lies not in the battles recorded in the sagas. Perhaps it lies in the way they transformed limitation into innovation. And perhaps we still haven't fully understood what that means. Throughout the centuries, history has taught us that progress always moves forward. But Viking technologies tell a different story. They reveal that human knowledge doesn't advance simply by accumulating new inventions. Sometimes it leaves entire paths behind, solutions based on observation, patience, and coexistence with nature, not on attempts to dominate it. The Vikings did not possess modern machines, industrial energy, or formal science as we know it today. Even so, they created ships capable of crossing hostile oceans, houses that breathed in harmony with the climate, materials that lasted for centuries, and social systems prepared for uncertainty. None of this happened by chance. It was born from a deep attention to the world around us. Today, scientists are rediscovering these technologies not as historical curiosities, but as silent reminders that intelligence doesn't depend solely on technological advancement. It depends on understanding. Perhaps the true genius of these inventions doesn't lie in the past. Perhaps it lies in the question they leave for the present. How much knowledge do we still ignore because it seems too simple? If this type of historical content sparks your curiosity, consider subscribing to the channel to continue exploring forgotten stories, discoveries, and knowledge that still have much to reveal. Because sometimes understanding the future begins by looking again at what we already knew.